Okay, what we're going to be doing now is finding the trigonometric ratios of a given right triangle. They're going to introduce some new ones. We've known cosine, we've known tangent, and now is the first time you're going to see cosecant. Okay, cosecant, which is this one right here. Okay, so there's your typical SOHCAHTOA, which we know very well. Okay, we know SOHCAHTOA very well, and that's these ones right here. All right, but what is going to be introduced in the next couple topics is their opposites, which is cosecant, secant, and cotangent. Okay, so this is the way it goes. Um, Cosecant, and this all should be in your notes. This absolutely must be in your notes. Okay, put this in your notes. Like it says, good stuff for the ACT. Okay, even if you're not taking it, still good stuff. All right, so cosecant. What is cosecant? It's abbreviated CSC, okay? So the cosecant is going to be the hypotenuse over the opposite, which is the opposite of sine, because we know sine is opposite of hypotenuse, but cosecant is actually going to be a hypotenuse over opposite. So it's the opposite of sine, which it's also equal to 1 over sine of theta. So those are both the same things, okay? Secant is the next one you're going to see. It's the opposite of cosine. So cosine is adjacent over hypotenuse, but secant, which is abbreviated SEC, is going to be hypotenuse over adjacent, okay? Which is also it's 1 over cosine of theta. And then cotangent, that's your last one. Cotangent is going to be the opposite of tangent. Instead of being opposite over adjacent, it's adjacent over opposite, as it's abbreviated COT, and it's also equal to 1 over tangent of theta. So, all right, so that's all stuff that should be in your notes, little mini quick lesson on that. And then let's go back to the problem. So we're going to need to find cosine, tangent, cosecant of the angle estimated, okay? So um, oh, they want exact values. I'm sorry. They want exact values, not decimal approximations. Okay, so exact values is going to make this a little tricky because we're going to need to know all sides. Well, that's not that big of a deal because we're given two sides, right? And we know that this is a right angle. So that comes to our famous little theorem, Pythagoras theorem, okay? That tells us if a squared plus b squared equals c squared. Well, if this is a, that's b, right? And c will be the hypotenuse. C is always the hypotenuse. So here we go. So if that's going to be a squared plus b squared equals c squared, where c squared is always the hypotenuse. A, in this case, I'll just call 5. So I got 5 squared plus 6 squared equals c squared. Okay, and now I'm going to solve this. Well, 5 squared is 25, and 6 squared is 36. C squared is just c squared. Okay, well, then we're just going to simply add these two together. So we got 25 and 36. It's going to give me 61 is equal to c squared. Well, to get what c is equal to, now I'm actually going to take the square root of c squared, which is going to give me c is equal to square root of 61. And yeah, it is plus or minus, but minus doesn't make sense in this context. So it's going to be the square root of 61, okay? All right, now let's take this to the problem now, all right? So the problem says it wants cosine, it wants tangent, and it wants cosecant, okay? So let's fill that all out. All right, let me give myself a little bit of room, okay? Well, like we said, this side is square root of 61. Okay, so cosine of theta is going to be equal to the adjacent over the hypotenuse. Okay, and which is going to be equal to, in this case, because this is going to be my adjacent, that's my opposite, and obviously this is my hypotenuse. Okay, so adjacent is 5, so 5 over, I wrote hypotenuse wrong. That should be an HYP. 5 over the square root of 61. Okay, So now, that would be all good and fine, but we got to rationalize this denominator. That denominator of the square root of 61, Alex is not going to take that, and it wants exact answers. So what I'm going to multiply by is the square root of 61 over the square root of 61. Okay, because really that big thing in blue right here is a 1. All right, it doesn't change the value of the problem, but what it does do is 61, square root 61 times square root 61 is just simply 61, and then on the top we'll have 5 root 61, okay? All right, so, and that's your final answer for cosine, but you still got to do the other ones, okay? So this is cosine, cosine's done. Now we got to jump over to the next one on the list, was which was tangent. So tangent of theta is equal to opposite over adjacent, which is going to be, in this case, 6 over 5. And you know what? We're done. That one's done. That was easy, okay? And now we're going to do cosecant. There's always one hard one in here, okay? That was the tangent in this case, or cosine in this case. So cosecant of theta is going to be equal to the hypotenuse over the opposite. Got that from my notes up here, okay? Hypotenuse is square root of 61 over the opposite, which is 6. And I'm done with that too, all right? Why am I done here but not there? Because that radical's on the bottom. So if that radical's on the bottom, I'm good, or the radical's on the top here. If the radical's on top, we're okay with it. If it's on the bottom, that's a no-no, okay? So, yeah, we're done. That's all we needed, all right? You gotta write those three values in there. It wants exact answers, and you're done.